So the answer for this question is 2.63 second inverse. So now that we have calculated the KD values for all the different temperatures, we have been asked what? We have been asked to calculate the time it takes for 1 meter cube of the medium to be treated. So if with this, keeping this in mind, we know that number of cells is 10 power of 8 cells per liter, and we know that 1 liter is equal to 10 power of minus 3 meter cube cells per liter. 10 power of 11 cells per meter cube. So now N0 is equal to 10 power of 11 cells. And what is N0? N1 or N, which is 10 power of minus 3. N is usually the at the end of sterilization, how much will be remaining. So it is N is 10 power of minus 3 cells. So when you substitute this in the formula, N naught e power of minus kdt, which is nothing but 10 power minus 3 is equal to 10 power 11 e power of minus kdt. So if you take it to the other side, it is that of minus kdt is nothing but 10 power of minus 14 is equal to e power of minus kd into t. So minus kdt is equal to, take ln on both sides. kdt is minus 32.24. T is equal to 32.24 divided by kd. So we have come to this expression and we have calculated previously the kd values for each of the different temperatures which was asked in the question, which is 80 degrees Celsius, 121 degrees Celsius, and 140 degrees Celsius. So going back, now substitute the kd values here to find the answer for the question asked. At 80 degrees Celsius, T is equal to 32.24 divided by your kd is 2.11 into 10 power of minus 6. And if you do that, this is our second inverse, right? Check what would be the answer. What would be the answer? It is 32.24 divided by 0.11 into 10 to the power minus 6. Yes, it is coming around 15 point into 10 power of what is that? 6. Yes. So now convert it into hours. So what you have to do? Whatever you were getting, it is 10, 15 point. 15.27 into 10 power of minus 6 divided by 3600 or 60 into 60 to convert it into hours. So 7 into 10 power of 6 divided by 60 into 60. It is coming around 424 hours. So if you are using 80 degrees Celsius to sterilize 1 meter cube of media, it would take you 4,244 hours. Then think about how many days it would come. So if you convert it into days, so it's going to be around 176.8 days approximately. So using this would be a waste. So using this space, I ran out of space. Okay. So let's again write it somewhere here. Okay, I'll use the space and then we will rewrite. So in case of at 121 degrees Celsius, if you would like to use the same condition at 121 degrees Celsius, so repeat the same thing. T is equal to 32.24 divided by KD. KD for 121 degrees Celsius, which we calculated. This 32.24 divided by 0.049. What we have calculated before? 0.048 second inverse. 48 second inverse. And calculate this, check what would be the answer. Thirty-two point two four divided by 0.048 is around 671.66. Now converting this in terms of, this is second inverse, right? So if you convert this in terms of minute, 671.66 seconds. So how many minutes it would be? Divided by 60. It's going to be around 11.19 minutes. So it would take you, if in case you are using 121 degrees Celsius to process the 1 meter cube of media, you will require only 11.19 minutes. So if you are using 140 degrees Celsius, then what would be the time required to sterilize 1 meter cube of media? Just 32.24 divided by KD, which is, what was the KD which we calculated? KD for 140 degrees Celsius is 2.63 seconds. Inverse 2.63. So 32.24 divided by 2.63 is roughly around 12.25 seconds. So if you are sterilizing, then it will take at 140 degrees Celsius, that would take you around 12.25 seconds only to sterilize the 1 meter cube of media. So let's move to the next question. This is the last question. An autoclave malfunctions and the temperature reaches only 119.5 degrees Celsius. The sterilization time at the maximum temperature was 20 minutes, and the jar contains 10 liter of complex medium that has 10 to the power of 5 spores per liter. At 121 degrees Celsius, KD is equal to 1 minute inverse and ED is equal to 90 kilocal per gram moles. And what is the probability that the medium was sterile? Let's take few minutes to read the question. So let's start solving it. So what are the given values? Time is given, which is 20 minutes. And the volume is given as 10 liters. And the spores is, let's calculate N naught or the spores or initial spore concentration is given. It is 10 to the power of 5 spores per liter. Per liter, we know the volume is 10 liters. So multiplying it, plus 10 power 6 spores. And what else is given? KD is 1 minute inverse and time is given as 20 minutes. So multiplying it, 1 into 20 minute gets cancelled. So it is 20 only. So you have been asked, what is the probability of successful sterilization? So we have done it before. The probability of successful sterilization is equal to 1 minus e power of minus kdt, the whole power of n naught. So sorry, this was previous question. So 1 minus e power of minus 20, the whole power of 10 to the power 6. Solve it. The answer will give you probability of successful sterilization. First, let's find the probability of successful sterilization and then we'll proceed to find out the unsuccessful sterilization. So what is the answer? The answer is around coming around 0.9979, right? So the question is, instead of reaching 121 degrees Celsius, the temperature has only reached 119.5 degrees Celsius. So what do you think would be the probability that the medium is still sterile? So let's calculate the KD value with respect to 119.5 degrees Celsius and then see what would be the probability of successful sterilization. So converting your 119.5 degrees Celsius into Kelvin, It is 273. If we add, what is the value? 119.5 plus 273 is 392.5. It's nothing but 392.5 Kelvin. So this is one. So Kd is equal to e power of minus e by RT. So as from the previous problems, we can substitute the values. 10 power of 36.2 is your A value, and e power of minus 283 divided by 8.314 into 10 power of minus 3 into 392.5. If you solve this, you will get the value of Kd. Solve this and get the value of Kd. So it is 283 divided by 8.314 into 10 power of minus 3 into 392.5 minus 86.7, which is minus 86.72. E power of minus 86.72 into 10 to the power of minus 36.2. This would give you Kd value is equal to 0.0345. So now, similar to the uh, what we have done here with respect to 121 degrees Celsius, calculate the KDT, multiply by the instead of KD 1 minute inverse here, we have got it as 0.0345. So now KDT is equal to 0.0345, because instead of keeping for 120 minutes at 121 degrees Celsius, it has not reached 121 degrees Celsius in the 20 minutes. So still the time is 20 minutes, right? So let's keep it as 20 minutes. So what would be KDT value is 0.0345 into 20, which is 0.69. So now, similar to the previous, how we solved the section A, solve it. P naught T, this is what 0.69, right? So P naught T is equal to 1 minus e power of minus 0.69 into 10 to the power of 6. Solve this and find the answer. E power of minus 0.69 is 0.5015. 10 power of The answer is 0. This answer would be around 9792, and this is coming around 0. That means the probability of successful sterilization becomes 0. That means that your sterilization is not going to happen. So I hope uh, this session has cleared some of your doubts. So this is the final question which we have solved. If you have any doubts, you can ask. Otherwise, we can end the session right now. Upashna, there will be one more session, which is next week. That's also, as this is an 8-week course, the 8th week lectures will be discussed in the next class, which is on 5th, I think the next Saturday, same timings. After that, there will be no more live sessions for this course. Thank you. Thank you. Thank you for joining, Upashna. Sure. Give me a minute, Prasanna. I'll just go to the question. So, is this where you are talking about? Yes. So, N1 is what it is given as 10 to the power 6 organisms per centimeter cube. But your volume of the reactor is given in decimeter cube, right? So, how much is decimeter cube? It is 1000 centimeter cube. So, N is equal to 10 to the power 6 organisms per centimeter cube into, I am multiplying with my decimeter cube is my volume. So, instead of the centimeter cube, to convert your, or either you have to convert your decimeter cube into centimeter cube or centimeter cube into decimeter cube, right? So let me convert my decimeter cube into centimeter cube. To convert that, 1 decimeter cube is equal to 10 to the power c centimeter cube. So I'm multiplying it by 1000 so that my centimeter cube or decimeter cube will become converted to centimeter cube. So this units gets cancelled. N1 is not the concentration but the amount or the number of viable cells. So that's why 10 power 6 into 10 power 3 into 10 power 3. It is just the conversion. Were you able to get it, or shall I explain it again? Okay, Prasanna, thank you. So sorry, I have missed recording from the start. I was able to record in the middle only. So to rectify, I'm re-recording it as a continuation. So please, please look into this. So let's start. So the question is about in batch sterilization, it is difficult to get ideal temperature time profile. So the answer for this question is true. The next question is with the increase of superficial air velocity, the collection efficiency of the impaction decreases, whereas the collection efficiency of diffusion increases. The answer is false. In case of ungassed Newtonian fluids, the power required for laminar flow is independent of the viscosity of the fluid but proportional to the fluid density. The answer for this question is false. And the question is about scale up. And the question is successful scale up requires geometrical similarity, dynamic similarity, or it needs both. Actually, it needs both geometric and dynamic similarity. So the next question is power number NP in a bioreactor is constant when Reynolds number is, the answer is greater than 10,000. So let me solve the problems because the recording was missed when I was solving. So I'm re-recording it. So the question is a large scale bioreactor with 10,000 liter complex medium containing 10 to the power of spores per liter is being sterilized. The del factor value for the system is 15 and using the following information, which is the gas constant R and the conversion of Celsius to degree is given. Determine the probability of successful sterilization and also in section B, determine the probability of unsuccessful sterilization. So let's start solving the problem. So it's given that the total number of spores is N naught, can be written as N naught into V, which can be 10 to the power of 4 spores per liter into your volume is 10,000 liter. So this gets cancelled. which is nothing but 10 to the power of 8 spores. Your del factor, which is nothing but Kd into T, is given as 15. So let's assume that all the viable cells or the spores or organisms are identical, and the probability of extinction or death of the total population P naught T is P naught T is equal to 1 minus P of T the whole power of N naught. So what is P naught here? P naught T means the probability of extinction or death of the total spores. And your P of T is nothing but probability that a spore or a cell or organism will still be alive at the time period of T. So let's write probability time T. And N naught is nothing but number of the spores initially present. Spores or organism at time T is equal to 0. So now how do we proceed? So if we assume that the first order death model, we can then substitute Pt is equal to e power of minus kd t. So then the equation becomes P naught T is equal to 1 minus e power of minus kd t the whole power of n naught. So substituting the values which we know, 1 minus e power of minus 15 the whole power of 10 power 8. So if we solve this, what would be the answer? The answer would be 5.18 into 10 power of minus 14. This is nothing but the probability of extinction or death of spores, which is equal to your probability of death or extinction, which is equal to probability of, if there is death of cells means what? There is a successful sterilization. So this is nothing but it is equal to probability of successful sterilization. So what was the next question? Next is probability of unsuccessful sterilization, right? So B is to determine probability of unsuccessful sterilization, which is nothing but 1 minus probability of successful sterilization. So the value would be 1 minus 5.18 into 10 power of minus 14. So what would be the answer? So the answer is approximately 0.999. It goes on like that. So it is close to 1. So the next question is, media is to be batch sterilized in a 200-liter fermenter before it is used to grow microorganism, and using 0.001 as the probability of an unsuccessful sterilization. Ignore heat up and cool down. The information given below is for Bacillus stereothermophilus, which is known as an most heat resistant organism. So for the Bacillus stereothermophilus spores, which is present in the media, which may be present in the media, the spore concentration is 10 power 8 spores per liter. E is, or your activation energy for thermal death, is 67.7 kilocal per mole. A is Arrhenius factor or constant, is 10 power 36.2 minute inverse. R, which is the gas constant, is given as 1.987 Kelvin inverse, mole inverse. And you are asked to find the value of Kd in terms of hour inverse at 121 degrees Celsius. So I have given, we started solving the problem. A is 10 to the power of 36.2. R value is given as 1.987. E is given as 67.7 kilocal. So I have converted it into instead of kilos, I have written 10 power 3. To convert the temperature into from Celsius to Kelvin, 121 plus 273 has to be added. So the temperature comes around 394 Kelvin. So with this, how do we proceed to find the value of Kd? So what relationship can be used to find the answer for all the terms which are given and Kd? So we can use Arrhenius factor or Arrhenius constant. Kd is equal to A e power of minus Ed by RT. So substituting the values which we have noted down from the given values, let's write it down. 10 power of 36.2 into e power of minus 67.7 into 10 power 3 divided by 1.987 into what was your temperature? It's 394. 394. So if you solve this, what would be the answer? From this, we can calculate the value of Kd. So this would come around 10 power of 36.2 into e power of minus 86.5. So if you solve 10 power of 36.2 into e 2.78 into 10 power of minus 38. So this gives you what would be the answer? So that would be around 0.044 minute inverse. To convert it into hours, we know that 1 minute is equal to 60 seconds and 1 hour is equal to 60 minutes. You multiply instead of 60, then this becomes 2.64 hour inverse. So KD value is 2.64 hour inverse. So let's go to the next question. So the question is, sterilization is being carried out in a 10,000 decimeter cube pilot scale vessel. The medium contains 10 power 6 organism per centimeter cube. The probability of unsuccessful sterilization is given as 1 in 1,000. You have been asked to determine the del factor for this probability of the contamination. And during the scale up, where a bigger reactor is used, which is around 10,000 decimeter cube, with the same medium as in the previous section, which is given. Determine the del factor for the large vessel if the same probability of contamination is required. So write down the given values. For part A, the volume is 10,000 decimeter cube. 1 decimeter cube is equal to 1000 centimeter cube. So convert it 1000 into 10 to the power 3 centimeter cube. Now for N1, the organism is 10 power 6 organisms per centimeter cube. Multiply it by your volume, which is 1000 into 10 to the power 3 centimeter cube. So this gets cancelled. So it is around 10 to the power 12 organisms. So the probability of unsuccessful sterilization is nothing but your, at the end of the sterilization, the remaining viable spores. So that is given as, let's take it as N2, and that is given as 1 in 1000. So it can be written as 10 to the power minus 3 spores. So what have been asked? The del factor for the probability of contamination. So the del factor is nothing but KDT. So KDT is nothing but KDT is given as ln of N1 by N2. So substitute the values. Ln of N1 is 10 power 12 divided by N3 is 10 to the power minus 3. Just ln of 10 to the power 15, which can be, what will be the answer? So the answer is around 34.5. So what was the next question asked? During a scale-up, the vessel is going to be increased, the size is increasing, but it is given that the same medium is going to be used and the same probability of contamination is required, which means that N2 is the same, which is 10 to the power minus 3. N1 is going to differ because the volume has changed. So 10 to the power of the spores, how much was the spores? 10 power of 6 organisms per centimeter cube. Now the volume has changed. So it is 10,000 decimeter cube. So if you convert decimeter cube into centimeter cube, you are going to multiply it by, again. So cancelling 10 to the power of, how much it is? 4 into 3 organisms. So if you are substituting this, when you are substituting this in the previously mentioned formula, 10 power 6 into 10 power 4 into 10 power 3 divided by, this is 10 power minus 3. So this goes here. So ln of 10 power 16 is giving you around 36.84, which is the KD or del T value when the volume of the reactor has been increased from 1000 decimeter cube to 10,000 decimeter cube. Let's go to the next question. Please take some time to read the question. So here in the question, a steam sterilizer is used to sterilize the liquid medium for fermentation. The initial concentration of contaminating organism is 10 power of 8 organisms per liter. For design purposes, the final acceptable level of contamination is usually taken to be 10 power minus 3 cells. So this corresponds to a risk that one batch in 1,000 batch will remain contaminated even after the sterilization process is complete. You have been asked for how long should be 1 meter cube of medium be treated if the temperature is 80 degrees Celsius, B temperature is 121 degrees Celsius, and C temperature is 140 degrees Celsius. To be safe, assume that the contaminants present are spores of Bacillus stereothermophilus, one of the most heat resistant organisms known. So for these spores, the activation energy for thermal death is 283 kilojoules gram mole inverse, and the Arrhenius constant is given as 10 power of 36.2 second inverse. So how shall we proceed with the question? So you have been given the values, whatever necessary. Then you have been asked for treating 1 meter cube of the medium. What would be the time required if the temperature is 80 degrees Celsius and 121 degrees Celsius and 140 degrees Celsius? Take few minutes to read the problem and then we'll go to solve the problem. So let's start solving the problem. So the given values are A is 10 power of 36.2 second inverse. Your depth constant or activation energy is 283 kilojoules gram mole inverse. Rate gas constant is 8.3144 joules Kelvin inverse gram mole inverse. Let's convert it into kilojoules. 8.3144 into 10 power of minus 3 kilojoules gram mole inverse. So now converting the temperatures into kelvins, 80 plus 273, 121 degrees Celsius equal to 121 plus 273, 140 degrees Celsius equal to 140 plus 273. So what would be the values? It is for 80 degrees Celsius, the answer is 353 Kelvin. The next one is 394 Kelvin and 140 is 413 Kelvin. So now what we have to do first is identify the KD value from your Arrhenius equation. Sure. So for the first, it's 80 degrees Celsius, KD is equal to E is 10 power of 36.2 into E power of minus 283 divided by 8.3144 into 10 power of minus 3 into 353 Kelvin. So find out the answer. This will give you the value of KD. So what would be the answer? The answer is 2.2, sorry, 2.11 into 10 power of minus 6 second inverse. So similarly, do it for 121 degrees Celsius. It is KD is equal to 10 power of 36.2 into E power of minus 283 divided by 8.314 into 10 power of minus 3 into, now substitute the value of the Kelvin value of your 121 degrees Celsius is 394 Kelvin. So if you calculate, what would be the answer? This is into, this will come around 3.018 into 10 power of minus 38. So if you solve this, it's coming around 0.0478 or approximately 0.048 second inverse. So similarly, sorry, for calculating for 140 degrees Celsius, then it would be 10 power of 36.2 into e power of minus 283 divided by 8.314 into 10 power of minus 3144 into 10 power of minus 3 into 413. So how much it would come? E power of minus 283 divided by 8.314 into 10 power of minus 3 into 413, give around e power of, sorry, 10 power of 36.2 into 1.60 into 10 power of minus 36. Fix all this into 10 power of 6.2. What would be the answer? So this is coming around 2.54 second inverse. So now we have found the values of KD for different temperatures which we have been asked. So now we'll find the relationship of finding, we know the relationship between the number of cells and time. How do we know? We have been using the same formula. We know that N by N naught is equal to e power of minus k dt. How did we come to this equation? From the expression kdct is equal to ln of L naught by N. This can be brought. So now we know N by N naught is equal to e power of minus k dt. We need what? We need the time. We want to form a relationship between time. So now substitute the values which we know. So what is the relationship between number of cells and time? So we know that the cell concentration is given as N naught is equal to 10 power of 8 cells per liter, and the media is given as 1 meter cube of media, which is nothing but 1 meter cube is equal to 10 power 3 liters. So multiply it by the volume. This will give you 10 to the power 11 cells, and the n value, that is the final number of spores after sterilization, is given as how much? 10 power of minus 3 cells. So your n value is 10 power of minus 3 cells. Now substitute this in this expression. Means n is 10 power of minus 3. This is 10 power of 11 equal to e power of minus k dt. which is nothing but 10 power of minus 14 equal to e power of minus k dt. So now removing the e term, how do we remove? Taking if you take ln on both sides, ln of 10 power of minus 14, ln of e power of minus k dt. This gets cancelled. So it becomes ln of 10 power of minus 14 is equal to kd into t. So what would be the value? Ln of 10 power of minus 14 is around minus 32.24, which is equal to minus kd. Sorry, I missed the minus kd here. Wait. So minus minus gets cancelled. With respect to t, 32.24 divided by kd is the expression between your kd and t. Now you know the answers for kd. So kd at 80 degrees Celsius is what? And you know kd at 121 degrees Celsius. You know the kd value at 140 degrees Celsius. So what are those? That was around 2.11 into 10 power of minus 6 second inverse. For one, this is 0.48 second inverse. For this, how much it was? It was around 2.54. 2.54 second inverse. So now you know the values of kd. Substitute this in this equation here and find out the time for each temperature. So for the first thing, at 80 degrees Celsius, T is equal to 32.24 divided by kd. It's nothing but 32.24 divided by 2.11 into 10 power of minus 6. What would be the answer? So 32.24 divided by 2.11 into 10 power of 6. That is 1.5 into 10 power of 527 into 10 power of 6 seconds. So convert into hour. 1 second is 1 hour is equal to 3600 seconds. So dividing by it is nothing but how much would be the answer? So that would be 1.527 into 10 power 6. It is around 424 hours. So similarly, at 121 degrees Celsius, 322 point into 0.048, which is nothing but 32.24 divided by 0.048 is 1.6 seconds. This, when you convert it into minute, you have to divide it by 60. 1 minute is equal to 60 seconds. It will give you around 11.19 minutes. So similarly, calculate for 140 degrees Celsius. It is nothing but 32.24 divided by, what was that? It is 2.5 seconds. What would be the answer? So the answer for this is around 32.24 divided by 2.5 is nothing but 12.89 seconds. So if you want to sterilize 1 meter cube of media at 80 degrees Celsius, it would be taking you around 4,244 hours. So how much it would be if it is converted into days? So 1 day is equal to 24 hours. So if you convert 4244 hours into days, it will be 4244 divided by 24. It is coming around 176.8 days approximately. So if you want to sterilize your 1 meter cube, that is 1000 liter media at 80 degrees Celsius, that would be costing you around 177 days or 4244 hours. So if you use for the same volume of media, if you use 121 degrees Celsius, that is going to be taking around 11.19 minutes, approximately 11 minutes. And if you are using the higher temperature of 140 degrees Celsius, it is going to be around only 12.89 seconds. That is what we infer from this problem. So I hope you have understood the problems. I have resolved it again. I think I have solved it. I was able to record this question. Thank you for joining.